Have you ever really thought about what's happening between your car's engine roaring to life and the wheels actually turning? Well, today we're going to pull back the curtain on that unsung hero of your car, the transmission. And to really get why it's so important, we have to start with a really basic question, right? I mean, it seems so simple. The engine makes the power, the wheels need the power, so why can't we just connect them? Why do we need this complicated middleman? It's a fantastic question, and it gets right to the heart of the matter. And here's the answer. An internal combustion engine is kind of like a world-class sprinter. It's incredibly powerful, but only in a very specific comfort zone. If you make an engine spin too slowly, it'll just cough and stall out. But if you try to make it spin way too fast, you're risking a total meltdown. It has a sweet spot where it works best, and it really doesn't like to leave it. So you see the problem, right? The engine wants to stay in its happy place, spinning at a pretty consistent high speed. But driving in the real world means you need to do everything from being at a complete stop, to crawling in traffic, to flying down the freeway. There's a huge mismatch between what the engine wants to do and what you need it to do. And this is exactly where the transmission comes in. You should think of it as a master translator. It takes the very specific, high-speed language of the engine and translates it into the flexible, variable speed language that the wheels need to handle any driving situation you can throw it at. It's the ultimate mechanical diplomat. So, how does this magical translation happen? Well, the answer is one of the most brilliant and timeless pieces of engineering ever created: gears. Okay, but before we can really get gears, we have to talk about something called torque. To put it simply, torque is just twisting force. Think about it. When your car is parked, it has inertia. It wants to stay still. Torque is the raw muscle you need to overcome that inertia and get all that heavy metal moving. And this chart here lays out the whole trade-off perfectly. In a low gear, like first, you get a ton of torque. The engine is spinning fast, but the wheels are turning slowly. This setup multiplies the engine's force, giving you that powerful push in your back when you take off from a red light. You've got massive power, but not much speed. Then you shift to a high gear, like fifth. Now the opposite is true. The engine can relax and spin much slower. You have less raw torque, but your wheel speed is way up. That's what lets you cruise efficiently on the highway without your engine screaming. So, we know gears are the key, but how do we actually control them? Well, this is where two totally different philosophies come into play. The manual transmission, where you're the boss, and the automatic, where the car is calling the shots. But remember, they're both just trying to solve the same problem. If you're driving a manual, you are the translator. It's a three-step dance. First, you press the clutch pedal, which breaks the connection between the engine and the transmission. That little pause allows you to move the gear lever and select a new gear ratio. Then you release the clutch and boom, the power is reconnected, flowing through that new gear. It's this really satisfying direct mechanical connection. Now, the automatic transmission is designed to do all that thinking for you. Instead of a clutch that you control, it has this amazing device called a torque converter. The best way to think of it is like having two fans facing each other. If you turn on one fan, the air it blows will start spinning the other one. A torque converter does the same thing, but with fluid, which lets your engine run smoothly even when your wheels are at a complete stop. And deep inside, a whole maze of gears is shifting all by itself. And today's automatics are, well, they're incredibly smart. They've gone way beyond simple mechanics. They use a whole bunch of sensors and a computer, a brain, really, to watch your speed, see how hard you're pressing the gas pedal, and even detect if you're driving up a hill. And it uses all that information to pick the absolute perfect moment to shift, all to give you the smoothest ride and the best possible fuel economy. And then there's this other breed, the CVT, which basically just throws the whole idea of separate gears right out the window. Instead, it uses a pair of pulleys that can change their size, connected by a strong belt. By making the pulleys wider or narrower, it can create a totally seamless, infinite range of gear ratios. It's a brilliant piece of engineering because it means the engine can just jump to its most efficient speed and stay there while the car accelerates smoothly underneath you. So, for more than 100 years, the transmission has been one of the most critical parts of any car. But now, a new technology is completely rewriting the rulebook. Let's talk about how the electric car is changing everything. And this is the game changer. Electric motors just don't have the same problem that gasoline engines do. They don't have that narrow sweet spot. An electric motor can deliver incredible torque right from a dead stop, and it works super efficiently across a huge range of speeds. Because of that, most EVs don't need a complicated multi-gear transmission at all. All they need is a simple single-speed gear to reduce the speed a bit. It is a total paradigm shift. So, after all that, from manuals to automatics to the future of EVs, what's the one big idea you should take away from all this? Why have we spent all this time talking about this part of the car that most people never even think about? This. This right here is the most important thing to remember. A transmission isn't a power source, it's a power manager. It takes the raw, chaotic power from the engine and skillfully tames it, shapes it, and delivers it to the wheels in a way that makes driving possible, efficient, and controllable. The story of the transmission shows how a piece of technology can get so good at its job that it just becomes invisible to us. And as it starts to fade away in this new electric era, it really makes you wonder, right? What's the next complex system working silently in the background of our cars that we're completely taking for granted today? What's the next thing we'll be making an explainer about a few decades from now?